What is correlational research? Once researchers describe the variables they're investigating, they can use statistics to examine how they are related to one another. When one variable increases, for example, what happens to the other variable? Correlational research attempts to find out. This method measures the strength and direction of the relationship between two or more variables. It does not involve any kind of manipulation. Researchers simply collect the data without intervening. As a result, though, correlational studies cannot determine causation. They cannot tell us which variable caused the other variable to change. These graphs are called scatterplots. Each dot represents where a human being falls on some measure. These scatterplots illustrate a few examples of the relationships we might investigate. What is the relationship between the temperature outside and the number of people who purchase cold drinks? What is the relationship between the temperature outside and the number of people who wear sweaters? What is the relationship between the temperature outside and the number of people who have the hiccups? One of the statistics researchers calculate is called the correlation coefficient. It describes both the strength and the direction of the relationship between variables. Here are the basics of understanding what the coefficient means. First, we look at the number. It will range from -1 to +1, but perfect correlations like this are rare. When the number is closer to 0, it indicates the relationship is a weak one. So, a correlation of 0.2 is weaker than 0.4. When it's closer to 1, it indicates a strong relationship. A correlation of 0.9 is stronger than 0.6. Second, we look at the sign associated with the number. A positive sign means the two variables move in the same direction. As one increases, so does the other one. As one decreases, the other one decreases too. A negative sign means the variables move in the opposite direction. As one variable increases, the other variable decreases. When you see a correlation coefficient, you will want to be able to interpret it. This GIF does a great job of showing you the correlation coefficients of various scatterplots. When the dots are spread apart, the correlation coefficient is closer to 0, indicating a weak relationship. As the dots begin to cluster, the coefficient moves further away from 0, indicating a strong relationship. Let's review some of the advantages and disadvantages of this method. First, correlational studies are easier to conduct than experiments, and they can be done in laboratory and field settings. This method is also useful when it's not possible to manipulate one or more of the variables, like age, gender, and race. As you know, the main disadvantage of this method is that it does not tell us which variable caused a change in the other one. It can only indicate the existence of a relationship. Imagine we want to know if there's a relationship between watching violent television and behaving aggressively around other people. We could randomly select a group of adults and ask them to complete 2 surveys, one that measures how much violent television they watch, and one that measures how aggressive they behave in real life. Even if we find a relationship between the 2 variables, we won't know whether watching violent television causes aggressive behavior or whether aggression causes one to prefer violent TV shows. Another problem with the correlational method is that it doesn't rule out extraneous variables. For example, it could be that a third variable, intensity of family troubles, is related to both watching violent television and aggressive behavior. It could be the key to understanding how and why the other 2 variables have a relationship. Now that you are familiar with correlational research, you will review the gold standard in the next lecture, experimental research.